this is Mahantesh. Today I am explaining about first part of squares and square root of class 8 of CBSE syllabus. So today I will explain some basic things of the chapter squares and square roots. Here I am going to cover the definition of a square and examples of square and properties of square numbers. Within that, how to identify the last number of the square number and what are the square numbers of some few numbers. And third, I will explain some interesting patterns of square numbers. Within that, I will explain you adding triangular numbers we will get one square number, how it is possible, and other how to find the numbers, how many numbers are there in between two square numbers. So this much I will cover in this video. First, let us explain me what is a square number. Square is what we know. The square is having all sides are equal, so the length of each side of a square is equal. Similarly, suppose we want to find a square number, we have to multiply that number twice. That is, suppose we want to find the square of 2, 2 into 2 is 4, 3, 3 into 3 is 9. So we can find a square of any number multiplying that number with itself. Example, so I can write 1 into 1 is 1 square, 2 into 2 is 2 square, and this is 1, this is 4. Multiplying 2 twice we will get 3 into 3, we are getting 3 square, and this is 9. So on, we are getting the square number. These are all called as square number. 1, 4, 9, and next one will be 16, next one will be 25, next one will be 36, and next one will be 49, next one will be 64, next one will be 81, and 10, the square of 10 is 100. So coming to the properties of square numbers, here see the square numbers end always with 1, 4, 9, 6, 5, 0. So the square numbers always ending with 0, 1, 4, 5, 6, 9. So these are the numbers always end with every square number. So identifying the end numbers of a square number. Suppose I have a big number 1, 2, 3. What is the end number of this 1, 2, 3? So when we multiply, this will be a big number. So without multiplying, I can find what is the end number of this 1, 2, 3. So the last number is 3. 3 is multiplied twice. It will give us 9. So 9 is the end number of the square of 1, 2, 3. That is 123. Suppose I want to find the square of 1, 2, 3, 4. So its end number will be, for the 16, the 6 will be the end number of this. Suppose it is like this. What is the last number of the square? So 0 is the last number of square. Suppose it is like this. So what is the square number of this? The 1 into 1 is the last. So 1 is the last number of square number of this. This is, suppose, any number ending with what is this? 5 square. So the 5 is the last number here. 5 5 is 25. The last number of this square is 5. So this is one property. Any number you can square. However it is large, you will get the last number always end with 0, 1, 4, 5, 6, 9. These are the last numbers of the any square numbers. Now let me come to the interesting patterns of the square. Now let us see interesting patterns of square numbers. See what happens. That to adding triangular numbers. What are the triangular numbers? So 1, I will write 1 star. Next I will write another. So 1 star is earlier. Now I will write another 2 stars. So this is 1 star. It is also triangular number. This is 3. 1 plus 2, 3. I have added next stars to this. First one, I am adding 2 stars. Now I have to add 3 stars. So this is 1 plus 3, 1, this is 3 star, it is, I am adding 1, 2, 3, this is 6. Similarly, now I will add one more 3, 4. Earlier it is 3, now it is becoming 4. Earlier as it is we have to write, and this is 2 and this is 1. So how much? 1, 2, 3, 4, 7, and this is 10 stars. Similarly, next suppose we go here, we will get 15 stars here. So the last row will be 5 stars, and here 4, and here 3, and here 2, here 1. So the total count will be 15 stars. So these numbers are called as triangular numbers. So what is the special property here? Suppose I add these two triangular numbers, I will get one square number. Again, suppose I add these two triangular numbers, I will get another square number. Suppose I add these two triangular numbers, I will get another. Suppose I add these two, I will get one more. This is 16. 5, 9, yes, 25. Right? 25. So this is a square number, that is 2 square. This is a 2 square, this is 3 square, this is 4 square, and this is 5 square. So this shows that adding triangular numbers we get square numbers. This is the first property. Adding square number, what we will get? We will get a square number, 2 square. Adding these two, I am getting 4. Adding these two, I am getting 9. Adding these two, I am getting 16. And adding these two, I am getting 25. This is one of the special interesting pattern of the square, triangular numbers. Suppose we add any two consecutive triangular numbers. Any two consecutive. Consecutive means first one, second one. First one, second one. Again these two. These two. These are called as consecutive triangular numbers. So adding any two consecutive triangular numbers, we will get a square. Now coming to special property, how to find the numbers between the two square numbers. Suppose there are two numbers. What is that number? First number I will take 2 and 5. What are the natural numbers lie between these 2 and 5? I mean squares of these two numbers. I have to take as 3, not 5. So what are the numbers between 2 square and 3 square? What is 2 square? This is 4 square. 4. And what is 3 square? That is 9. So what are the number here? 5, 6, 7, 8. Right? 5, 6, 7, 8 are the numbers between this square, square numbers. These two are square numbers, and these are all natural numbers. Right? So another formula is there to find this is 2n plus 1. So n is this, n plus 1 is this. 2 is n, then 3 will become n plus 1. So what is this now? 2. The n is also 2 plus 1. This is 2 to the 4, 4 plus 1, so 5. There are 5 natural numbers beside this. 1, 2, 3, 4, 5. Or we can find non-perfect square numbers. Non-perfect. These are perfect square number, including this. So non-perfect square number will be identified by the formula 2n. What is 2? 2 is that, and n is 2 here. So 2. So this is 4. There are 4 non-perfect square numbers are there. There are 4 non-perfect square numbers are there. So this is how we have to find the numbers between two squares numbers. Suppose I will take 12 and 13 square. What are the numbers, non-square numbers available between the squares of 12 and square of 13? Then what is n here? n plus 1. So n is 12. So the total non-square numbers between 12 square and 13 square is 2n. Therefore 2 into 12. So that answer is 24. There are 24 non-square numbers are there between the squares of 12 and 13. So this is the second property of the square numbers. Okay.